The next algorithm is cluster analysis. And cluster analysis is really looking at how do certain groups of data, how do they get grouped together, and can we find proximities in certain records of data which are grouping around certain values. Now that could be, for example, if you look at your customer segment, we might find that part of your customer segment are men in the age of 35 to 45 who have a high income. And another customer segment might be women in the age of 25 to 35 who have an average income. And another segment might be young people, either man or woman, but they have a very low income, they're students, and they have different characteristics. So in this way, we can detect different segments in the client base, and we do that on the basis of data and on the basis of commonalities in that data using the cluster analysis algorithm rather than just experience and intuition, which may now no longer be valid. We're using the digital customer information in order to do our cluster analysis and our segmentation. Another algorithm is anomaly detection. Anomaly detection is used to detect when is something not normal. So for example, the banks use this quite actively and for quite some time. So if somebody normally spends a couple of thousand euros or pounds per month on groceries or on buying various items, and then suddenly on their credit card they've spent €3,500 buying 6 of the latest model iPhones, that's a bit of an anomaly. That's not a normal transaction. Or normally they might buy this sort of technology good in a local technology shop, but suddenly this purchase has been made in Thailand on the other side of the world, and no other purchases are in that region. Now we have an anomaly, so we have an expected profile of behavior, but we have an event which is well outside that profile. It's a sort of outlier. This is anomaly detection, and it's used frequently in, for example, the financial services industry. And the other algorithm is association discovery, and association discovery is really looking for patterns. When one type of event happens, does it get followed by another event and another event, and can we link these together? Do they associate? Are they related to each other, and does this happen more often? And that's been used in fraud cases where we see certain, perhaps estate agents and notaries and dubious merchants are collaborating together to perform a fraud, and they do this frequently, and it's always following a certain pattern. That's really the sort of association that we're looking for with the association discovery algorithm. Now, all of these algorithms that I've described so far are from the more traditional world of sort of data analytics, and the algorithms have been around for a long time. And if you think of it in this way, when we provide data to these algorithms, we are, it's like a spreadsheet. We have rows and we have columns. And basically we are providing the data and we are also indicating what the columns are. And we call that feature analysis. We are providing the feature analysis to the algorithm, and the algorithm's taking that data, linking the input to the output. The other approach is that we do not provide the features, we do not provide the columns, and that approach is deep learning. And with deep learning, essentially what we're providing is a bunch of data and saying that's one output, and more data is another output, but we don't describe the features of the data. We let the computer do the feature analysis, as we call it, feature extraction. And this is the case, for example, with images. When we train our algorithm, we're basically giving it a large number of images, and we might say, this is a man, this is a woman, this is a man, this is a woman, showing all the different pictures. And we let the algorithm determine what are the features in the image, that are explaining that this is a man or that this is a woman. So the algorithm is doing the feature extraction, and if I simplify it, it's like we don't have columns, but the algorithm is identifying the columns in order to classify the data as man or woman. So in summary, these are the most common algorithms. We have the algorithms where we are providing the data as a structured input, classification, regression, time series forecasting, cluster analysis, anomaly detection, and association discovery. And then we take a step forward with deep learning, where we do not provide the columns, we don't provide the features, we're providing a data set and letting a neural network, a deep learning algorithm, determine the features for us. And that's a great step forward in the world of AI. And later in the course, we'll come back and discuss some of those applications and show you how that works.